Okay, guys, let's talk about light-independent reaction, also called carbon reactions. Second part of photosynthesis, when we make sugar, where the magic happens. We have used the light energy from the sun. We have harnessed it in form of ATP and NADPH molecules, electron carriers. Our output, our waste was some oxygen, but we just shed it away because it's a waste. We don't like it. We plants, we rock, and we work with carbon dioxide. Our carbon reaction use that carbon dioxide. So it uses the three carbon dioxide to start with. And it's going to be similar to the Krebs cycle in respiration, but slightly different, similar in the way that in the sense that it's using Pigol as well, and it's also a regenerating cycle, which means that it's going to use the end product of RuBP with the CO2 thanks to the Rubisco enzyme to regenerate itself. So really important. I'm not getting into as much detail as in respiration of how those things work, but you have 3 CO2 plus RuBP, which by the way is usually in 3 with it's a phosphorylized carbon molecule that has like I think 5 carbon and a phosphate group on either side, right? That's RuBP right for you. And that is with 3 CO2 making unstable intermediary. So that's what we call the carbon fixation step when we just get the CO2 and the RuBP together in unstable byproduct. So we don't really need to remember what's happening. We enter now the actual Pigalle synthesis. So how do you go and make some Pigalle out of an unstable thing? Well, those unstable reaction components will stabilize in complex ways, but we're not gonna just go through them. 6 PGA molecules, right? So that's all you need to remember. 3 CO2, 3 RuBP, and they make 6 PGA. How do you know it's 6 PGA? And how do you know it's 3 carbon molecule? Well, count the carbons, right? 3 times 5, 15, plus 3, 18, right? 6 times 3, 18. And here you go. If you know you have 6 PGA, you know RuBP is a 5 carbon molecule because you know you have 3 CO2, so you need 15 more, and you need 5 times 3. You got it, right? So you can just do a little bit of easy math to find that out. Your 6 PGA will have a huge reaction here to make those Pigol, 6 Pigol molecule. And that huge reaction, let me kind of redraw that it's on the board. That those reaction here, that's where everything kind of happens in the carbon reaction. You use all the ATP. Let me actually move that whole board up because we don't need to see about the CO2 anymore. You use all the ATP from your light reaction, so it's 6 of them. You use all the NADP plus DPH, 6 of them as well. And you use those to do all that change of a PGA to Pigol, because Pigol, remember, it's that 3 carbon molecule, right? And it still has its phosphate here. So it looks similar, but remember those are just the carbon backbone. It's different than the Pigol, although it's a 3 carbon as well. That's why you don't need to add carbons or take carbon away here. All you need is to use energy to reconform that molecule of PGA into a molecule of Pigol, right? And in the process, you get ADP plus P, and you get NADP plus H plus, right? So you do that, and you have like actually 6 of those because you start with 6, right? So that's how you get your Pigol. The Pigol, you count the carbon, 3 times 6, 18, and you have 3 times 5, 15. So the regeneration of that Pigol into RuBP only requires 5 Pigol to do such thing of regenerating RuBP. You only need 5. And you need some energy that's coming from respiration. It doesn't actually come from the light reaction. And I think it's 3 that you need. And I believe it's 3. And like, of course, plus P. So you use some energy to make that P-goal, but you only need 5 P-goal to get the RubyP back to start over your cycle again. What do you do with the last one? There's 1 P-goal that actually goes out, and you accumulate it, and over several cycles, actually 2, because 1 P-goal is a 3-carbon molecule. If you have 2 of them, what do you have? A 6-carbon molecule. What is a 6-carbon molecule, guys? C6H12O6. It's glucose, it's sugar. And here you have it. You can make sugar by doing that over and over again. Lots of light out there, lots of energy, lots of time, lots of carbon dioxide out there. So there's a lot of resources for plants to go through that entire cycle. And that's really what I want you to remember. Be able to draw that. Remember, count the carbon, walk your way through it, and at the end, you only need 1 P-goal molecule to actually accumulate. You don't take more because you need to regenerate. If you don't regenerate that RubyP, you cannot start the next cycle. If you cannot start the next cycle, you cannot make the next P-goal, right? So here you have it, carbon reaction. And that's all for this time. You guys remember the 3 steps: carbon fixation, P-goal synthesis, regeneration of RubyP. And the last one here, important as well, making sugar. That's what plants use for cellulose, starch, sucrose, anything, right? Okay, I'll see you in the last video for photosynthesis in a bit. You guys take care. Bye-bye.